In this video, we will be looking at section 2.2. We're dealing with solving quadratics, specifically the quadratic formula. This is part 2 of the video. If you have not seen part 1, you should do so. All right, we're going to get right into an example of how to use the quadratic formula. Example. Let's use the problem that we closed with in our last video. Using the quadratic formula. Using the quadratic formula. The first thing we're going to have to do, step 1, is set our equation equal to 0. And this is a common first step with our solving quadratics. We often have to set the equation equal to 0. So in this case, in order to set this equation equal to 0, I need to subtract this 12. Alright, so subtracting 12 from both sides of the equation. 12 minus 12 yields the 0 on the right hand side that we're seeking. And these are all unlike terms. One's an x squared, one's an x, one's a constant. They can't be combined. This becomes x squared minus 9x minus 12 on the left. That is step 1. Step 2, we will identify A, comma, B, comma, C. And A, B, and C are from our form ax squared plus bx plus c equals 0. This is the form for the standard form for quadratics. A is the coefficient of x squared, B is the coefficient of x, and C is our constant term. So in this case, A is 3, B is a negative 9. In this context, it's subtraction, but for the purposes of what is B, we use the negation, because we see our form is plus b. Alright, so we should, b is equal to negative 9. Lastly, c is our constant here. Again, we will consider this operation, and c will be a negative 12. Okay. Once you have correctly identified a, b, and c, you are ready to use the quadratic formula. Substitute, step 3. Substitute into the quadratic formula. Alright, and this is the bane of many an algebra student's life, is memorizing this quadratic formula. Well, in my class you won't have to memorize it. I'll always give you access to it. The quadratic formula states that x, or whatever our variable is, will be equal to negative b plus and minus, because we're typically going to have two solutions, the square root of b squared minus 4 times a and c, all divided by 2 times a. Alright, and it looks really intimidating, but it's just a matter of simple substitution of all these values in here for a, b, and c. So in our particular case, x will equal negative b. Well, since b is negative 9, negative 9 is positive 9. Plus and minus the square root of b squared. That is negative 9 quantity squared. When you're putting this in your calculator, make sure you put the negative inside the parentheses, the squared outside. Minus 4 times a and c. Well, a in our case is 3. C in our case is negative 12. All divided by 2 times our a value of 3. Alright, that is step 3. Step 4, we will solve and check. Solve and verify. Okay, So x equals, I'm first going to simplify my radicand. That is this number underneath the square root. So negative 9 squared is 81. 4 times 3 is 12. 12 times negative 12, I should say in this context. Negative 12 times negative 12 is 144. 81 plus 144 is 225 underneath the square root. We know we've called this number previously the radicand. In the context of our quadratic formula, this value takes on a different name. All right, it is still the discriminant. All right, but we also call it is still the radicand, but we also call it the discriminant. All right, this value is called the discriminant. It will tell us about the nature of our roots, our answers. If it's positive, we will have 2 real solutions. If it's 0, there will only be 1 real solution. And if it's negative, we're going to have 2 imaginary solutions. That is, we'll be employing the value I, which we discussed in 1.7. All right. This is all divided by 2 times 3, which is 6. Okay. Well, the square root of 225, that's 15. So this becomes x equals 9 plus and minus 15, all divided by 6. So now we're going to go in 2 directions with this. We have 2 different expressions. We have 9 plus 15 over 6 and 9 minus 15 over 6. 9 plus 15 divided by 6. And separately 9 minus 15 divided by 6. This because our square root we consider both the positive and negative. 9 plus 15 is 24. 24 divided by 6 is 4. And 9 minus 15 is a negative 6. Negative 6 divided by 6 is negative 1. X is equal to both of these values, 4 and negative 1. I could take that and substitute it back out into the original, but from the last, we've already done that in our previous video. 4 and negative 1 are solutions. These 2 values, x equals 4 and negative 1, they are solutions. They do satisfy my equation. All right, and that concludes this video.